Okay guys, let's go on to my last video, and I'm going to be talking about more and more examples on balancing redox reactions, and this would be the last video on the theories and general chemistry uh, videos, and hopefully later on with a lag I would go on and post more videos on other subjects in chemistry, including organic maybe, or uh, symmetry things, or maybe some physical chemistry videos. So let's go on and do our final session on general chemistry with redox balancing redox reaction. Let's do a case that is a little bit complicated. ClO2 giving me ClO2 minus and ClO3 minus. What do I do in a case like this? So it's definitely chlorine that is changing. It's changing from here to here, and it's also changing from here to here. Here it's just +4 on both counts, okay? But in this part, it goes from +4 to chlorine -6 is -1, so it's +5. So it's kind of rather one of a raise, okay? And in this one, if you look, it's going still from +4 to here. Chlorine -4 is -1, so it's +3. So it's one of a drop. Now, how do I do this when I have two coefficients from one source? Then I would look back to my right side, to the product side, and I would do the same exact thing. So I don't have underscripts here. Now I look for the underscripts also here. If I want to put these two and exchange it for the product side. One would go here, another one would go there, and here's one chlorine, so I do two chlorines here. I don't have any hydrogens, so story simple, and I could go on and put the rest of the work here. Okay, let's go on and see how many oxygens I do have. I have 5 oxygens here and 4 oxygens here, so I need to add 1 oxygen to this part. In the acidic media, I would do 1 H2O and 2 H pluses, and in the basic media, I would do ClO3 minuses. I would add 2 OH minuses and an H2O. And if you check the charge, you've got two negative charges here, -1, also -2, -1, and a +2, so 0, and also 0 here. So that's also balanced. Let's move on to yet another example where you have one of those things changing at the same time. Okay, let's see if we could do that. Let's go to this example where I have H2O2 giving you O2 and H2O. Oxygen is certainly one of those that is changing. H2O2, you have to know the structure for it, or else I would give the oxidation state of oxygen here. It's -1 rather than the normal -2. Okay, so oxygen here goes from -1 to 0, and it's a rise of 1. Okay, and if I want to put the coefficients on the product side, because the other one is also there, it's also from here -1 to a -2, so it's a drop of 2, a drop of 1. Okay, now for this, there's no underscript, I don't need any coefficients, it's just 1. But for this one, there is a 2, so 2 times this. Okay, a rise of 2, because again there's one substance and I want to put my coefficients on the product side rather than the reactants. So I put the 2 for H2O, and I put the 1 there. Here's 2O2 and another 2, so I'll be 2 H2O2. That's this. Let me check if the hydrogens are balanced. So I have 2 H2 and 2 H2, so that's also balanced, and I don't need to do anything for this. This is how we balance this. Let's go on to yet another typical example. We've done many of those typical examples so far, but let's just do one more. Let's do NO3 minus plus H2SO3, giving me SO4 double minus and NO. So here I've got nitrogen that goes from N minus 6 equals minus 1, so it's plus 5, to N minus 2 equals 0, so plus 2, and it goes from 5 to 2, so a drop of 3. And here S plus 2 minus 6 is 0, so S is plus 4. S minus 8 is equal to minus 2, so S is plus 6. And it's a drop, it's a rise of 2. Now the 2 goes for NO3, and the 3 goes for this 3H2S, so 3S, 2N, so 2N. Now I could get rid of this, and since I have 3H2 here, I have to add 3H2O. Also, let's rewrite it one more time here. So if we count the number of oxygens, we will have 3 times 3, 9 oxygens and 6 oxygens, so 9 and 6, 15. 3 times 4, 12, and 2 and 3, 5, and 12, 17. So we have to add 2 more to this. Let's count one more time. 5 here and 12 here. Yes. So we need to add 2 oxygens to this place. Okay, and if I want to add 2 oxygens to this part, it means I have to add 2 H2Os, which means just left 1 H2O here, and on the opposing side it was 2 H2O, so 4 H pluses. Okay, let me just write that down so that it would be a better representation. Plus 4H plus. My bad if it's a little bit how to say, it's a little spaced. Let me see. Yeah, you could certainly see it, but it's a little bit, how to say, packed together, but no problem, we could still see that. Here we have still the 3H2O, so we do double the amount of that, so 4 OH minuses, and to compensate we add 2 more H2Os, and that would be 5 H2O. And that's how you do this. Let's count the charges. You've got 2 negative charges here, you've got 6 negatives and 4 plus. That would be also 2 negatives, so that's balanced. 4 negative charges here and 2 negatives, so minus 6, and also 3 times minus 2, minus 6. It's balanced on both sides, so that's this. Let's just get rid of this small sense over here and then go to more examples. I believe at the time that we have, although this one would be a short video, so it would be good enough for us, but let's see, we could still do more examples. Let's do this one. P4 plus HClO giving us H3PO4 and Cl minus. So let's do this. Chlorine goes to chlorine, minus 1, and here is plus 1 chlorine, minus 2 0, so chlorine is plus 1, and from plus 1 to minus 1 it's a drop of 2, and there's no indices. P4 here is going from 0 elemental state to P plus 3 minus 8, so P is it's 0 because charge is 0, so plus 5. And it's a rise of 5 and times 4 because we have 4 of those phosphorus. So we could get rid of these 2 and also 2 of this, so 2 times 5. The 10 goes here and the 1 goes for the phosphorus, 10 HCl, so 10 Cl minuses, and then we're going to take care of the hydrogens. So So I have 10 hydrogens here and only 3 hydrogen. Oh, this should be 4, because 4 phosphorus and 4 phosphorus, okay, when we balance. So 10 hydrogens here and 12 hydrogens, so plus 2 hydrogens. If I want to add plus 2 hydrogens, oh, my bad. Plus 2 hydrogens means H2O on this side. Okay, that would make 12 hydrogens, 12 hydrogens. Now let's count oxygens and do the oxygens. If I have also, let me quickly rewrite it for a second time, that I would do H2O plus P4 plus 10 HClO, giving me 4 phosphoric acid and 10 Cl minus. That's the entire equation. Let's just count oxygens. We have 10 over here and 1 over here, so 11, and we have 16 over here, so I got to add 5 oxygens to this side. If I want to do so, it means adding 5 H2Os here. It means this becomes 6, and add also 10 H pluses to the other side. Okay, so 10 H plus and 6 H2O. Also here it means 10 OH minuses and 5 H2O. The 10 OH minus could actually replace this if I just subtract 1. I could get this, and I could move this 10 OH minus as right where you could clearly see. Okay, that's it. Now let's count the charges to see if we've done a good job on this. So there's 0 charge here, literally. 10 minus 10 plus, also 0, balanced. Minus 10 over here and minus 10 over here, also balanced. That's this. Let's move on to do yet another example. I believe maybe we could do a simple example. Let me see the depository of questions that I have right here for you. Okay, let's do this one. My bad, I apologize for the time delay. I have to just make sure that I'm not doing something that is repeated previously, so that's I'm just going through all this. So, and again, this is one of those that is like, I have to admit it's got H in it. SNO2 double minus, giving you SNO3 double minus, and also BiOH3. Okay, so that's this. Let's just go to the equation. I've got bismuth 3, so it would be bismuth minus 6 is minus 1. Bismuth should be plus 5. Make sure you see this. It goes to here, which is bismuth minus 3 is just 0, and that would be plus 3. So it goes from 2 of a drop, and there's no underscript on that. Sn minus 4 is minus 2, so Sn is plus 2. And here Sn minus 6 is minus 2, so Sn is plus 4, so it's 2 over ice. Okay, so that's this. We have to just replace the 2. We could simplify that, and that would be 1 by bismuth 1 Sn, 1 Sn, 1 bismuth. So that's that. Okay, already balanced. For the sake of hydrogens, I have 3 hydrogens here, but none there. Let's just make 3 hydrogens, so 3 halves of water. Okay, if we have 3 halves of water, then I'm going to actually count the number of, actually let's do multiply everything by 2. So 2, 2, 2, 2. Maybe I would simplify it later on, but for now it's just 2, just to get this 3 halves to be correctly represented. So 3 oxygens here, 6 oxygens here, 3 and 6 is going to be 9, and another 4 is going to be 13. Okay, here I have 6 oxygens, another 6, so 12, so I have to add just 1 oxygen to this site. Okay, and that means I'm going to do H2O, which is going to be subtracted, and also I'm going to add 2 H pluses to this site. Okay, because if I do 1 H2O, I have to add 2 H pluses to that site, and it makes this one 2 H2O. Okay, and let's just rewrite the equation one more time. We just forgot to do this. 3H2O plus 2 BiO3 minus plus 2 SNO2 double minus, giving us 2 SNO3 double minus and 2 BiOH3. So for the basic, still I have to do double the amount of OH minuses, so 2 OH minuses and 1 H2O, so it would be 4 H2O. And if you look, I could get rid of all the 2's on the top, because everyone has one, and I don't need a reaction that is double. And over here, I could get rid of all the 2's as well, except for this one, which goes to a 2, because 4 divided by 2 would be 2. So that's how you do that one. Let's now check the charges to see if the charges are good enough and see if we could wrap it up with this. So plus 1, minus 1, minus 2 is just minus 2, and this is minus 2 as well. So balanced, minus 1, minus 2, so minus 3, minus 2, minus 1 for the OH, so it's also minus 3. And that's also balanced. I believe we've done enough examples on redox reactions to make sure that you guys can possibly, with a good command, do balance these kind of reactions. The first step is to find out the metal and the non-metals, and then try to see how much of decrease or increase they have. If there are cases where you have one substance that goes to 2 changes on 2 different products on that other side, you could actually take those and also under scripts of the products and put those coefficients instead of the usual reactant side on the product side. Also, if we have hydrogen involved, we add H2O to compensate for that, and then we go add, we do balance oxygens, and when we do balance oxygen, we have to actually retouch or actually revisit our H2O numbers to make sure that if we have for example here 3 H2O and 1 H2O on the other side, we would actually subtract it, or we would add one more if it's H2O plus H2O. Okay, so that's it for this video. I hope you have learned a good deal of chemistry stuff in this series of courses, and I wish to see you for the later talks on most probably organic chemistry. Have a great time.